Good morning, everyone. Thank you all for coming. Today we will be presenting an alternatives analysis on the Palmdale to Burbank segment of California High-Speed Rail. Before we begin, we will introduce ourselves. My name is Christine Fisher, and I'm one of the project managers for the group.
And my name is Kyle Tran, and I'm the other project manager.
My name is Paul Marcinishin. I'm the design lead for Alternative 2.
My name is Nawame, and I'm the design lead for Alternative 3.
And my name is Dustin Dvorak, and I'm the design lead for Alternative 4.
I'm Dave, and I'm the design engineer for Alternative 3.
My name is Michael, and I'm the design engineer for Alternative 4.
Hello everyone, I'm Nigel Anthony. I'm the design engineer for Alternative 3.
I'm Golly Kleiner, I'm the environmental lead.
I'm Brenda Corona, I'm the environmental engineer. And now we'll hand it over to Kyle to talk about our project.
Thank you, Brenda. Again, my name is Kyle Tran, and to start off our presentation, I would like to briefly talk about our project location. As you can see on the bottom left map, our project locates approximately 30 miles north of Los Angeles City, and our high-speed rail segment begins from the city of Palmdale to the city of Burbank. And our alternatives alignments will be passing by city of Santa Clarita, as well as community of Acton and Los Angeles National Forest. The purpose of this project is to provide an efficient, reliable, high-speed rail service for the city of Burbank and Palmdale and their neighboring cities. Why is this project important? This project is only a small segment of a larger high-speed rail network that connects Northern California, San Francisco, to Southern California, San Diego. Moreover, projects like these will also help boost the economy by providing jobs to the local economies throughout the region that it passes. So far, High-Speed Rail Authority has already hired over 260 local businesses to help with planning, constructing, and design their high-speed rail segment. Secondly, there are only two existing major roads that connect Antelope Valley and San Fernando Valley. As you can see on the map, depicted by the blue line is the State Route 14, and by the red is the Metrolink Antelope Valley line. So this project will provide an alternative mode of transportation to connect the two valleys. Our project will also increase the connectivity of the mass transit system by choosing our station locations at the two transportation hubs. So the image on the left-hand side is the transportation center at Palmdale, which locates roughly 100 feet away from our proposed Palmdale station. And the regional intermodal transportation center at Burbank is located also about 100 feet south of Bob Hope Airport. So for the past 8 months, we have completed many tasks. So I would like to take some time to highlight the milestones that we have accomplished. First is the station identification, alternative scoping, geometric design, environmental analysis, recommendation analysis, and lastly, the project report. To design our alignments, we use two sets of standards. The first one is the California High-Speed Rail Authority, and the second is the Metrolink standard drawings. And with those two sets of standards, we come up with 5 typical sections for our alignments, and I would like to take some time to briefly go over them. Our station sections, we have 2 different station sections due to the fact that Palmdale station will be at an at-grade station, and the Burbank station will be 100 feet below ground, so it will be in a cut and cover shown down here. For our at-grade, we utilize cut and fill to minimize construction costs. And as you can see here, we have a slope of 1 vertical to 2 horizontal distance. And for aerial structures, we use that to minimize existing surface structures as of utility, major roadways, and other rail lines. Cut and cover, we use cut and cover to transition between at-grade to bored tunnels. And lastly, bored tunnel, which is used mostly to avoid environmental impacts and right-of-way acquisition. And at this time, I would like to hand it over to Dave to talk about the station selection process.
Thank you, Kyle. Again, my name is Dave, and we are going to talk about how we choose our station locations. So first of all, we need to find an ample space to put down our roughly 1,000 feet long station. Then we're going to look at the proximity of those station locations to the local transportation center. Then we go ahead and analyze the impact of those station locations on the surrounding area. Right, so first, in Palmdale, we chose to place our station at the corner of a Sierra Highway and Metrolink at the circle in red. In Burbank, we chose to place our station at the corner of North Hollywood Way and Winona Avenue. Then we go ahead and check the proximity of those station locations to the nearby transportation center. In Palmdale, as you can see, our high-speed rail station is located right across from the Palmdale Transportation Center, and they will be connected via a pedestrian overpass. While in Burbank, our station is going to be located within the Bob Hope Airport vicinity, while providing minimal walking distance to the local transportation center. Then we look at the impact of placing those station locations at those chosen location. In Palmdale, our station is located at that exact location to minimize the environmental impact as well as the disruption to private properties. To do that, we need to realign the Sierra Highway, which is located in blue over here, a bit further up north. In Burbank, we chose to locate our station underground to minimize the air traffic disruption above, while also minimizing the disruption to existing utility traffic flow as well as environmental issues. We then look at after identifying the two ends for our project, we then go ahead and identify 4 ideal alternatives for our project in 3 aspects. First, we look at each alternative goals, then we look at their geometric design, then we go ahead and evaluate the impacts of those alternatives on the surrounding area. So we have 4 alternatives. The first alternative is a no-build option. The second alternative will try to minimize the environmental impact. Alternative 3 will try to maximize the user benefit, and alternative 4 will try to be the most economical viable option. Then we go ahead and look at the geometric design of each alternative. Here, as you can see on the Google Maps image overlay, our alternative 2 is highlighted in red, alternative 3 is highlighted in yellow, and alternative 4 is highlighted in blue. And the 2 ends, the Burbank station and the Palmdale station is located at the bottom and top respectively. Now we're going to talk about alternative 1, which is the no-build options. Why did we even consider this option? Well, to offer no-build options means we're going to use the existing system, which consists of the State Route 14 and a Metrolink Antelope Valley line. Based on our study, we find out that the State Route 14 will meet a level of service F in 2040. What does that mean? It means you're going to have to stop and go every minute. And the Metrolink Antelope Valley line will share the same fate because they will need an additional track as well as more than 30 trains per day to accommodate for that growth. So in the end, we came to a conclusion that no-build options will be not feasible, so it would not be recommended. Now I will hand over to Paul to talk about our alternative 2.
Thank you, Dave. Hi, my name is Paul again. I'm going to talk about alternative 2. This alternative was designed with 3 goals in mind: to minimize the environmental impact by choosing a route around the Angeles National Forest as opposed to going through it, to increase constructability by breaking up the tunnels into shorter segments, and to avoid the community of Acton and the majority of Santa Clarita due to the strong opposition to the high-speed rail. This is our horizontal alignment. It is on the right, it's overlaid on Google Earth imagery. In blue is our tunnels, yellow is at grade, purple is aerial structures. We begin at Palmdale Station. Soon after that, we overcross Sierra Highway and enter one of the longest tunnels of our alignment. We then avoid the community of Acton entirely. We then reach daylight past Acton and continue through Soledad Canyon. Here we utilize at-grade cut-and-cover tunnels and aerial structures to create a cost-effective alignment. We then curve south and tunnel under the San Gabriels. We reach daylight in San Fernando and then travel along the existing Metrolink corridor for approximately 3 miles. Here we utilize aerial structures to cross local streets and to create a smooth profile. We then end at Burbank Station underground. Moving on to the vertical alignment, we begin at grade at Palmdale Station and we end 100 feet below the surface in Burbank. Our maximum grade used as shown here is negative 2.5%. This caps our speed at 168 miles per hour for that short segment. The minimum grade shown here is positive 0.25%. And then this alignment has 2 main tunnels. The first one on the left is about 15 miles long. The deepest part of this tunnel is 1,800 feet below the surface. The tunnel on the right is 11 miles long. Now, when designing this profile, we utilize long vertical curves to create a smooth profile as well as a comfortable ride for the passengers. Here's our track delineation, chart and figure. We have about 8 miles of at-grade track as shown in yellow, about 2 miles of aerial structured track as shown in the purple, and about 30 miles of board tunnel as shown in the blue. And our total distance is 45.76 miles. Now I'll turn it over to Brenda with the impact analysis.
Thank you, Paul. My name is Brenda, and we're going to talk about the impact analysis for Alternative 2. We designed this alternative with a couple goals in mind. We first wanted to minimize the right-of-way acquisitions by tunneling through the major community areas. We also wanted to make it the least environmental impact of the area by avoiding the Angeles National Forest. And we also minimize the number of grade separations. This table is a summary of the most important impacts of Alternative 2. We do share 3 miles of shared corridor with Metrolink. At this time, it is unknown the amount of utilities that may be disrupted. However, we do consider it as a major impact. We do impede 107 residential and business easements. We are within 1,500 feet of our center line to Coima Middle School. We have 0 landfills, 6 local street grade separations, 7 grade crossings by aerial structure, but no highway closures or highway grade separations. We also conducted a travel time analysis where our results indicated a total travel time of 17 minutes for both northbound and southbound directions, with a distance of 45.76 miles per hour and an average speed of 164 to 166 miles per hour, with a maximum speed of 220 miles per hour. We also did an analysis between speed and time. This graph illustrates while we travel from Burbank to Palmdale, also from Palmdale to Burbank, we increase our speed and we reach 200 miles per hour at about 3 minutes in. Then we reach a total speed of 220 miles per hour at about 7 minutes. Then we experience a steep terrain where we have to adjust our speed down to 166 miles per hour in order to accommodate for that. But once we pass that area, we increase our speed again and decrease as we reach the end of our destination. And now I'll hand it over to Nigel, who will talk about Alternative 3.
Hello everyone. Again, I'm Nigel Anthony and I'll be talking about Alternative 3, maximizing user benefit. To maximize user benefit, we decided that our alignment needed to minimize travel time as well as minimize the distance traveled. And to do this, we decided to have a very linear track as opposed to the previous alternative that curves around the SR 14, as you can see. We do start at Palmdale, just like the previous alternative, and as soon as we exit Palmdale, we begin tunneling throughout Acton, as well as the Angeles National Forest to reach Burbank. We make sure to tunnel underneath these areas as not to affect their environment, and also Acton doesn't want to have high-speed rail within their vicinity. We then reach Burbank 100 feet underground as not to affect the right-of-way or utilities. Here's our vertical alignment. Again, we start at Palmdale on the left. And as you can see, we have a cut and cover as is highlighted by the red. And once we hit the outskirts of Palmdale, we begin tunneling all the way to Burbank, which is seen there. Here are our highest grades and lowest grades. Our highest grade is 1.72 as shown by the red, and lowest grade is 0.38% as shown by the green. Having a low high grade means we are able to reach a maximum speed of 220 miles per hour and maintain that speed throughout the duration of the tunnel. Here is our track delineation. As you can see by the immense amount of light blue, we have a lot of tunneling. Approximately 90% of our track is tunneling. The tunneling, again, goes through the Angeles National Forest and makes sure that there's a lessened environmental impact. Now I'm going to hand it over to Noel to talk about the impact analysis.
Thank you, Nigel. Hi, my name is Amal, and I will be talking about the impact analysis for Alternative 3. So as Nigel mentioned earlier, our goal is not just was to minimize the travel time as well as the distance traveled. However, we also want to make sure that we hit these waypoints as well. We want to make sure we minimize the amount of right-of-way acquisition, avoid any relocation or disruption to any major utilities, and to minimize the number of grade separation. Because we are underground most of the time, we are able to achieve this. This is the summary, a table summarizing the impact of our alignment. We have zero disruption to any existing railroads. As of right now, there are no known information as to whether or not we have left any major utilities. We have approximately 94 properties we have to acquire, both residential and business. There is one school within a 1,500 feet proximity of the center line of our track, located in Palmdale, which is the RX Parish High School. There are no landfills within a quarter mile from our alignment, and we require no highway grade separation. So we also conducted a time travel analysis. So we determined that both the northbound and southbound track requires about 12.5 minutes to travel. Both tracks are approximately 32.7 miles long. The average speed for the northbound track is 156 miles per hour, and for the southbound track being 161 miles per hour. And both tracks were able to achieve a maximum speed of 220 miles per hour. So this is our graph showing the relationship between speed and time. As you can see that both trains are able to accelerate at a constant rate for approximately 4 minutes before reaching the maximum speed of 220 miles per hour. And both of the trains are able to maintain the speed for about 3 to 3.5 minutes before deceleration is required. And as we can see that there is a small discrepancy between the two tracks because both tracks aren't identical to each other. Our northbound track actually has a few more curves as far as that were taken into consideration when determining when conducting our analysis. And now I will hand it off to Dustin to talk about Alternative 4.
Thank you, Noel. My name is Dustin Dvorak, and I'll be talking about the design of Alternative 4, also known as the most economically viable. Our alternative was a combination of both Alternative 2 and Alternative 3. What we wanted to do for this was minimize the impact of the Angeles National Forest and minimize the travel time. Along with those two goals, we wanted to minimize the environmental impacts, including grade separations and right-of-way acquisitions. Here is a graphical representation of our alignment superimposed on Google Earth. As you can see, our alignment starts in Palmdale, and then travels south until it tunnels under the San Gabriel Mountains, where it will then curve southwest and finally daylight in Soledad Canyon, where it will run parallel to the Metrolink. Our alignment then curves south to go south again and goes into our longest tunnel, which is 18 miles, and finally ends in Burbank below ground. We have a total of 7 curves and a total distance of 40.9 miles. Here's our vertical alignment. We start in Palmdale at grade. Our highest grade is 2.27%, and our lowest grade is 0.74%. We have 2 tunnels, one the San Gabriel's designated in blue, and then our longest tunnel under the Angeles National Forest, also designated in blue. We have a combination of at-grade, cut and fill, and cut and cover tunnels throughout Santa Clarita. And our alignment will finally descend into Burbank, 100 feet below the ground. And our track delineation is represented here. We have our at-grade represented by yellow, our aerial represented by purple, and our tunnels represented by blue. Our at-grades add up to 6.49 miles. Our stations add up to a total of 0.53 miles. Our aerial structure, they will add up to 3.05 miles. For tunnels, 29.7 miles. Cut and cover, 1.39 miles. And we have a total of 40.9 miles. And now I'll hand it over to my colleague Michael to talk about the impact analysis.
Thank you, Dustin. My name is Michael Doan, and I'll be talking to you today about the impact analysis of Alternative 4. The main goals of this alternative were to minimize right-of-way acquisitions, highway grade separations, and major location of major utilities. In order to do this, we tunnel underground at Burbank Station in daylight around the San Gabriel Mountains. Here's a table showing our impacts. As you can see, we have 4 disruptions to existing railroads. There are no relocation of major utilities that we know of at this time. We have approximately 112 right-of-way acquisitions, and we are within proximity to a school within 1,500 feet of the center line called Arts Parish High School, located in Palmdale. There are no landfills that we are in proximity to, and we have 7 highway grade separations. Here's a table of our time travel analysis. As you can see, northbound and southbound show similar, with a travel time of 14.6 minutes and a total distance of 40.9 miles. An average speed of 167 miles per hour and a maximum speed of 220 miles per hour. Continuing on the time travel analysis, we conducted a speed bridging time graph. As you can see, our speed accelerates linearly until it reaches a maximum speed of 220 miles per hour around 4 minutes. We are then able to maintain that maximum constant speed for about 8 minutes, and at 12 minutes, the train decelerates back to the station. And now I'll be handing it over to my colleague Galia to talk about the environmental impact analysis.
Thank you, Michael. Again, my name is Galia Klein, and I'll be going over the environmental portion of this project. For the environmental analysis, we did a combined environmental impact report and statement. The purpose of doing this is to provide decision makers with all the information they need so they can make a well-informed decision. During the compilation of the report, we had to collect data from various sources, including ArcGIS, the California High-Speed Rail Authority, city business and general plans, the Environmental Protection Agency, SCAG Regional Transportation Plan, U.S. Department of Transportation, and the U.S. Geological Survey. We found that some of our key impacts include impacts to public utilities, critical habitats, hazardous materials, parks and open spaces, transportation, seismicity, air quality, and farmlands. Here are some of the key impacts specific to Alternative 2. This image shows hazardous waste sites in the area. We want to try and avoid these sites, and as you can see, Alternative 2 impacts many of them. Here again are some of the key impacts for Alternative 3. This image shows active fault lines in the area. As you can see, all 3 alternatives must cross both the Sierra Madre and San Andreas faults, and therefore mitigation measures such as grouting, isolation, or flexible joints must be used in these areas. Lastly, here's the key impacts for Alternative 4. This image shows farmland in the area. Wherever we are at or above grade, we will impact this land, and we want to try and protect as much as possible as it is a non-renewable land use. Therefore, we concluded that Alternative 3, the maximum user benefit, is the least environmentally impactful, and therefore it is our recommendation from this standpoint. I will now pass it over to Christine to talk about our recommended alternative.
Thank you, Gaia. Once again, my name is Christine Fisher, and I will be talking about our recommendation. So in order to compare one alternative against another, we first analyze the financial aspects for each alternative. To do this, we analyzed 3 benefits: reduction in delay, emissions, and wear and tear, and compared it against 3 costs: the support, construction, and right-of-way costs. To obtain the value for benefits, we used Caltrans and Federal Department of Transportation established values to come up with the total use a year. we see that alternative 3 is so far the most financially beneficial alternative. To establish a value of cost, we created an engineer's estimate for each alternative based on the estimate produced in the receptive precedent statement. Here we see that alternative 3 is the least costly alternative. Using these values, we created our benefit cost analysis by dividing our total benefits by our total costs. It is important to note that only the benefits for which a physical dollar amount can be assigned to were analyzed in this calculation. We then ranked each alternative, with 3 being the highest, based on their BC ratio. This rank becomes important as we look at our weighted decision matrix, which we established to evaluate the quality of each alignment in addition to the financial aspect as well. Here we list 7 factors. Each factor was a concern brought up by the local communities regarding this segment. We then assigned a weight to each factor based on their significance to the local communities, and then ranked each alternative with respect to that factor, again with 3 being the highest. We then multiplied that rank by the weight of the factor to obtain the score for each alternative, and repeated this process for the remaining 6 factors to come up with the totals you see at the bottom. We see that alternative 3 is not only the most financially beneficial alternative, but it's also the most viable in terms of quality as well. Therefore, it is our recommendation that alternative 3, which aims to maximize the user benefits, proceed forward into final design. We did create geometric drawings for each alternative. All 3 are shown on the wall to my left here, and alternative 3 is shown up on the board, which we do show our horizontal and vertical alignments along with the typical sections used in our inroads analysis and 3D simulation. The 3D simulation for our recommended alternative is shown here. We do have a website. All of the information presented here today is located on this site. We would like to take a minute to thank our advisors, Dr. Judel Gia, Mitch Alderman, Jason Brown, and Nicholas Crosskopf for helping us develop this project over the past 9 months. We'd also like to acknowledge Linda Bybee with the California High-Speed Rail Authority for helping us get this project off the ground, Manuel Ida III with the Cal Poly GIS Department, and Steve Austin with Esri for helping us obtain data for the region. And finally, Dan Trent for helping with some of our visual graphics. So once again, we'd like to thank you all for coming out, and we'll take any questions you have at this time.
What a great presentation. Any questions for our presenters?
I have a couple questions.
Yes, please.
Overall, California High-Speed Rail, there's been a lot of talk about ridership or lack of ridership. And I was wondering if you had a chance to look into that and how this segment that you've designed relates to the overall California High-Speed Rail.
I can take that. So we did actually look at the projected ridership both for when the platforms open